So looking at chapter 11 then, which is all about vectors. So we've seen these kind of at GCSE, but we are going to look at them in more detail. In the pure, then they don't come up too much, but they do come up a lot in mechanics, so you will practice using them and you will be able to get comfortable with them. So as it says here, a vector has both a magnitude and a direction. So remember, magnitude, that's the size, and the direction is obviously the way it's going. So you could say it's going that way, it could be going that way, but a vector has a specific magnitude and a specific direction. You can represent a vector using directed line segments. All that means is just a line. Okay, this next explanation about the vector PQ, really that's just overcomplicating it. All it's saying is that we've gone from P to Q, and then we've gone from Q to P, therefore your overall movement is actually, you've just ended back up at P. The direction of the arrow on the vector just shows the direction of the vector, kind of common sense, that bit. Okay, so the triangle law for addition vectors, so let's just look at this. All that's saying is that if you added this vector and this vector together, you'd end up with this vector. You don't need to go all the way along there and all the way along there. You can just go along there. Think about if you're walking a field. This is your field. You could walk along there and along there to get from there to there, but actually your easiest route is just going to be to go straight along, and that gives you then the combined size and the combined direction of those two walking routes. It would be exactly the same. That's really all vectors are about. So if you keep that in mind, then hopefully it will become a bit clearer. So looking then at example 1. Now this is very misleading. Honestly, it's so much more simple than what it looks. All it's saying is draw these lengths or these vectors all together. So as you can see, I've just done them in different colours just so you can see. So we've started here. So we've started at X. We've gone along A. We've then gone along B. And we've then gone down C. So as you can see, when we combine all of those vectors together, we actually just get the line which I've labelled XY. It's just along from X to Y. Another name for that is A plus B plus C, because it's all of those vectors added together. Okay, this part of the page is very misleading. You don't need to think of it as minus B. All we would do, if that was B, we wouldn't write minus B, we'd just put our arrow the other way. So just, that's just confusing it. Just think of it as the arrow being the other way. And this next section goes back to literally what we were saying before. If you have PQ, and that then is QP, well, you've ended up at your same place. You've not actually moved anywhere. You can multiply a vector by a scalar. That just means because it's got a magnitude, if you know that your magnitude is 2, you can times that by 2, which would give you a magnitude of 4. That would be in the same direction. It always says, but the same direction. It's just changed length. If the number is negative, as we said, you just put your arrow the other way. Any vector parallel to the vector may be written as lambda A. So you will see that all that lambda means is that it's a multiple. That's all lambda means. It's a Greek letter, but it does just mean a multiple. Therefore, you would know that it must be parallel. So if this was A and this was lambda A, this one here, you know that actually those are parallel. They're not the same length, but they are parallel because it's all around A, and A, remember, is the direction. We've just changed the magnitude there. So now we're going to take a look at example 2. In the diagram, so it just tells you what's written in the diagram. So find in terms of A, B, C and D, P to S, R to P. So basically you just need to find all those lengths. So if we're looking first of all at P to S, first thing I would do, highlight your 2 points. So we're going from there to there. You can choose any route you'd like. For me personally, I think the easiest is going to be to go from P to Q, and then we'll go from Q to S. So if we had P to Q, well, that we know is the reverse of this. So it's minus A, and then let's just rub that out so we can see a bit clearer. And then we're going from Q to S, which as we can see is just C. So we're adding on C. You can, as it says in the answer, so that's exactly what we've got. It then changes it round just because mathematicians don't really like to have the minus at the beginning. Either way round is not a problem. You can write it either way round as long as you've got a minus A and a plus C. So let's look at B then. So B is asking us to go from R to P. Okay, well hopefully we can see the easiest route is going to be to go from there to there and then there to there. So R to Q, well, that arrow's facing the wrong way. So all we need to do is do minus B, because remember the positive direction is that way. Therefore, the other way must be negative. So from R to Q, it's minus B, and then Q to P is just plus A, because that's what it says there. So exactly what it says there. Remember, you can just write your letters the other way around because it's a minus. So part C then. Hopefully we're getting the hang of these by now. Part C, we're going from P to T. Okay, well, remember, try and always use the labelled sides. So what we're going to want to do is we're going to go from there to there, then from there to there, and then there to there. So we're doing this one first. Well, it must be minus A, because we're going the opposite direction to that arrow. Then we've got plus B because we're going in that direction. And then plus D, because we're going in that direction again. So again, minus A, plus B, plus D, written in any order, not a problem. So then part D then, if we're looking at the last one here, is T to S. So we're at T, and we want to go to S. Okay, bit more of a tricky one, this one. Now, what the easiest thing is going to probably do is to go there to there, there to there, and there to there. Now, I'm not sure if I've already said this, but I'll say it again. It doesn't matter which track you take. If you were to go there, 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 any which way, you would get the same answer. Either way, any way. As long as you start where it's asked you to start and stop where you need to stop, you will get the same answer. So we're going from T to S. So we're going to do that way. So that's going to be minus D. We're then doing minus B. And then we're going along C. Example 3. ABCD is a parallelogram. AB equals A, AD equals B. Find A to C. So again, we're going to write on our points. We want A to C. So we're going to want to go along there. and then we're going to want to go along there. Now the key word here is actually what I've just covered over. It's this parallelogram. We know that this length and this length are identical. This length and this length are also identical to one another. They're not all the same, but the two pairs are identical. Therefore, if this, let's do it in a different colour. If this side here is B, this side here is also B in that direction. If the top side is A, these sides must also be A. So, to get from A to C, what we need is we need this B, so we've got B, and we need to add on the A. So it's B plus A or A plus B, either way round. So showing that two are parallel, quite common, and it does come up a bit later on in quite a bit of detail. All you need to do is be able to show that they are a multiple of each other. So if we've got 6A plus 8B, if we were to factorise that, we could take a factor of 2 out. So we'd get 3A plus 4B for that one there. So let's factorise this one. So we've got 9A plus 12B. Again, if we factorise, we can take 3 out. So we've got this time 3A plus 4B. Now hopefully we can notice that those two brackets are the same. That means that this vector has the same direction. It's not going to have the same length because the numbers are not the same. This is two lots of that vector, so if we were to draw that vector, so let's say that that's 3A plus 4B. So this one is saying that it's two lots of that line, where this one, because the multiple is 3, it's saying that it's 3 lots of that line. So 1, 2, 3. Where that top one, because our multiple was only 2, it's only 2 lengths. So it's just that one and that second one. And that's all it is. So to show they're parallel, you just need to have a bracket that is the same, because that means that it's the same direction. It may not be the same magnitude, and that's fine. But if we can show it's parallel, that's what it's asking for. Okay, so then let's look at example 5 in the triangle. So again, it tells you the lengths. Q divides AC in the ratio of 3 to 2. Write in terms of A and B, B to C. Okay, so we're going to find B to C. So the way we're going to do that, put our dots on. Okay, so we can see that we're going to have to go that way. We're told that AB, so A to B, that's that way, is A, and A to C, that's that way, is B. Therefore, in order to go from B, so from this point to this point, we're going to have to do the reverse of that side. So we're going to need to have minus A. And then we're going to have to go along that side as it says, so that's just plus B, which is exactly what it says there. So part 2 then, which is A to P. Well, we know that P, we're told P is the midpoint. We're told that. So therefore we know A to B, so that direction is A. So if you want A to P, it's still the positive direction, but remember it's going to be half of that because we're told that P is the midpoint. So it's just a half A for that one. Let's work that out. So part B is just a half A. So then let's look at part C. A to Q. Well, we know that A to C, we're told A to C is B. And we're told that Q divides AC in the ratio 5:3. Remember, if we've got our first ratio and our second ratio part, we need to get a total. So we do 3:2, so our total ratio parts is 5. That means section 1 has 3/5 because it's 3 out of 5, where section 2 is 2/5. So we want to find A to Q. So, well, A to Q is the 3/5 length. So it's going to be 3/5 of B because the whole thing is B, and A to Q is 3/5 of A to C. Bit of a tricky one there, but it's just a case of thinking about what length it's got to be. Okay, so then part D then is P to Q. Well, what you can do actually is just use what you've previously had in the question. So P to Q is there to there. What we're going to have to do is work out P to A first, and then we can do A to Q. Well, we've got P to A here, but remember that's A to P. Therefore, if we're going in the opposite direction, it must be negative a half A. And then we've just worked out A to Q. We've just worked that out, so we can take forward that answer. So it's plus 3/5 of B. So that there is your length from P